All right, guys, so next topic of interest, hand tracing a program. I actually don't do this very often because the debugger is better at it than I am. But I'll demonstrate it. Say we had a little program that looked like this. X equals 1, y equals 2, while x is less than 12. I'm not writing it as a perfect C program. Z equals x plus y, x plus equals y, whatever. And then maybe there's a print statement that's going to print something out. So I want to trace this. Normally what I would do is I would pop open Excel and create a little spreadsheet so that I could list the variables off horizontally. But honestly, I could probably just do that with another instance of Notepad, right? So, first line of code, what happens? It creates a variable x, and it sets it equal to 1. I'm going to be listing my variables across like this. Next line of code creates another variable called y, and assigns it a value of 2. Next line of code, well, that's just a while loop. Is x less than 12? No, it's not, because what was it equal to? It was equal to 1. So we dip into here. Z is equal to x plus y. So we create a third variable. And x plus y is 3. And then x plus equals y. That adds y to x, stores it back into x. So what's x going to equal now? After this line of code executes?
3.
Yep, going to equal 3. So this is changed from a 1 to a 3. Notice I'm not doing this, which you could, right? You could put, 1 every single one of them. But you really only need to note when it changes. Okay, and then we print out something. Who cares what we print out? We come back up, we check the while loop again. While x is less than 12. Well, 3 is less than 12. So we go back in here. Z is equal to x plus y. So in this case, x plus y. X is 3, y is 2, so z is equal to 5. And then x plus equals y? 5, right? Okay, yeah, so that becomes 5. And honestly, what's going to keep happening? It's going to equal 7, it's going to equal 9, it's going to equal, 11. And then after that, it's going to stop. Not going to bother doing the rest of it, but you saw what I was doing. You can use the debugger to accomplish the same thing. Let me just open a past project to demonstrate that. To use the debugger, you set a breakpoint, which will run the debugger to that point. So for example, this is one of our prior projects, I'm not sure which one. I'm going to put a breakpoint there. I'm curious about what happens when it gets to this point, and I run the debugger. Okay. This may have been a bad example, because I don't know what it's doing. Looks like it stopped there. It stopped there now. So I can come over here and inspect the so-called call stack. I can go over here and inspect the variables. At this point in time, x is equal to 1 and y doesn't have a value yet. So if I can find my little debug variable thing, which is right here, and I do step over, then it's going to go into that for loop. It's going to print something out. It's going to end the for loop, and it's going to come back to the top of the for loop again, and it's going to add 1 to y. That's what that's showing, and so we're going to see y increase from 1 to 2. And as we keep doing that, watch the variables change, right? Eventually, x changed to become 2. Right? So we're keeping watching it, right? So anyways, that's what the debugger does. Incredibly useful for figuring out what's going on. You hover your cursor over the variable and it'll print the value. It says x is equal to 3. Over here, the value of y is 6. Stuff like that. Extremely useful. It's more useful than call tracing. Very rarely do you ever have to do that, and if you did, you'd probably create a spreadsheet and do just what I was doing. Step through it in your head, line by line. I believe we're on lecture I, so just because I know it's coming up. Close my solution. Oh, when you're ready to stop debugging, you just press a little red square. It stops the debugger. You might want to remove your breakpoint so it's not there next time you open a project. Since I'm sure I'm going to need it, I'll open up lecture I. A case study. General Crates builds custom designed wooden crates. You've been asked to write a program that calculates the volume in cubic feet, the cost, the customer price, and the profit. So they've decided that their program is going to have these constants up at the top. The cost per cubic foot of the crate is 0.23, so apparently 23 cents per cubic foot. The charge for cubic foot is 0.5, so we charge them 50 cents per cubic foot. Costs us 23 cents. The length and the width and the height are the specifications for the crate. And then there's volume, which is going to be the number of cubic feet of the crate, which is just those three variables multiplied by each other. The cost is the volume times the cost per cubic foot. The charge is equal to the volume times the charge per cubic foot. And then the profit is the difference between those two values. So program design, we're going to ask the user to enter the dimensions of the crate. Then we're going to calculate the crate's volume, the cost of building the crate, the customer charge, and the profit made. Then we're going to display the results. Hierarchy chart. Here's what our program needs to do. It needs to get the crate dimensions, it needs to calculate the volume, the cost, the customer charge, and the profit, and then it needs to display all that calculated stuff. And we could actually write that program if we so chose. Guess we could, because they don't give us the answer. So let's write a program that'll do that. We'll simplify it a little bit. Add a new item, lecture.cpp. Lecture I.cpp, that is. Grab my good friend, the boilerplate. I know that when you use your laptops, if you make a console app and you don't make it an empty one, it goes ahead and fills it in with a little bit of boilerplate. All right. So it had some constants defined. Cost per cubic foot and charge per cubic foot. So const double cost underscore cubic underscore cubit cubic underscore foot equals 0.23, 23 cents. And now we're going to make a charge per cubic foot, which was 50 cents. Const double charge underscore cubic foot underscore cubic underscore foot equals 0.50, 50 cents. Now we need to ask them for the height and the width and the depth. Let's just pretend we did so that we don't have to type this data in every single time, right? So int h comma, or ht for height, no, h comma d comma w, height, width, depth. And I should use the whole words, right? Maybe I will. Height, comma, depth, comma, width. Then let the user input these values, but we're going to cheat. The height is equal to 2.5 feet. The depth is equal to 3 feet. And the width is equal to 1.7 feet, 1.6 feet. Now we need to calculate the volume. Well, I've already made a big mistake. I don't know why I made my variables ints. What's the problem with ints? They don't hold fractional numbers. I should have made these doubles. So I'm going to take that I and t there and change it to a double. Now I'm going to calculate the volume, which is just the height times the width times the depth. Double volume equals height times width times depth. Now let's calculate the charge and the cost. Well, the cost is volume times cost per cubic foot, and the charge is equal to volume times charge per cubic foot. So double cost equals volume asterisk and then all caps cost cubic foot, and then double charge is equal to volume times, and I seem to be, okay, it's underlining that, but the underline eventually went away. Volume times charge per cubic foot. And then the profit is the difference between those two. Double profit equals charge minus cost. Then we can print all that information out. And we might want to include IO manip so that we could set the precision to display, 2 decimal places, just like money is normally done. So coming back up to the top, so I can do that, I'm going to add # include less than IO MANIP greater than. Now down here, let's print some of this stuff out. But first, we want to specify what our precision is. So cout less than, fixed less than, set precision, no, it's just precision, isn't it? Wait, set precision, parentheses 2, in parentheses. That'll display 2 numbers after the decimal point, like dollars and cents. Now we're going to have several cout statements. We can print out the volume, the cost, the charge, and the profit. I don't know why I spelled profit without an I there, so I think I'll come back and fix that. So cout less than, volume equals $, end quote, less than, I said end quote. Where's my end quote? Come on. End quote, less than, volume, less than, ENDL. And since I'm going to type that 3 more times, I'm going to be lazy and just copy that entire statement and paste it. Paste, paste, paste. So volume, cost, charge, profit. You never want to show the user your cost, right? So maybe we shouldn't be displaying this, but this is for our purposes, not theirs. And then the cost variable there, the charge variable there, and the profit variable there. And there we go, right? There was the volume. Oops, volume should not have a $. That was dumb. And it should say cubic feet, right? Volume equals less than, volume, less than, quote space, cubic feet, end quote, less than ENDL. I just changed that line a little bit. Now the output will look a little bit better in my opinion. There we go. If we wanted to keep being fussy about it, we could try to line up all the equal signs and stuff like that. I think that's quite good enough there. Anybody have typos or need more time on the screen? Closing all the debug windows, and honestly I don't remember how to bring them back once I've closed them, so I shouldn't have done that. But alright, here we go. So what would we do to finish the program? We would just actually let the user type in the height, the depth, and the width. I think this is enough. I don't think we need to do more than that for this example. Are we all good? Really? Really? Nobody needs typing time? All right. Oh, the program was here. Let's compare what they did different than ours. Well, they declared all the variables beforehand. They set the I/O manipulators at the very beginning. Doesn't make much difference. They did ask for the input. The calculations are the same. And the output is a little bit different, right? They have cost to build, charge to customer, profit, right? They fleshed out the output just a little bit. Otherwise, it's very close. And that's the end of the chapter. We are done with chapter 3. Let's go look at the chapter 3 quiz. I know for a fact that if I don't put due dates on these things, they forget to be done. So I'm going to put a due date on this one. All right, so if you go in and click on quizzes, let's take a look at the chapter 3 quiz. Question 1. What header file must be included that uses CIN? Don't put the using namespace, just say what has to be included. So which of these header files here lets us use CIN and cout?
IOStream.
Yep, IOStream, the first one. So that would be the correct answer for that one. Assuming the following code, what will x equal if the user types in 3.14? We declare it as an int. They type in 3.14. The answer should be that, 3. The data will be rounded down. Now, I really hope that I don't put anything dumb like an error will be generated or whatever. I'll have to go back and check the key to make sure that that's the correct grade, but I always grade every one of these by hand anyways. Okay, next question. Like you can see this in the back row. Int x, y, z, please enter 3 numbers. Store the input into x, y, and z. If the user types in 10, 20, and 30, which variable will equal 31?
Z.
I hope the answer is okay. Yeah. And then it adds 1 to each one after you type it in. So x gets 10, y gets 20, z gets 30, and then 1 is added to each one. So it's z that becomes 31. Hope that makes sense. Assume the way to calculate meters is divide centimeters by 100. Given the following code, write the line of code that would replace the comment. So you've got a variable named m, you've got a variable named cm, and you want to calculate meters by dividing cm by 100. So what would I do? Calculate the meters. So it's going to start off with m equals, and then what's the rest of it?
CM divided by 100.
Yeah, m is equal to cm divided by 100. Yeah, that one doesn't have any possible answers. That question is borked. Sorry about that.
Please the expression with their value.
Oh,
Wait, yeah.
but
The value 1.
There's nothing to check against, though. There needs to be some code up here or something like that. Well, maybe I'm wrong. Yeah, value 1, value 2, value 3, value 4. Thank you for catching that. I don't know what my brain was. Okay, so which one of these equals 1? If we look carefully at it. Is 5 divided by 3 equal to 1?
Yes.
And it actually is, because these are both integers. So 5 divided by 3 is 1.4 or whatever it is, rounded down. So that's that correct one. And which of these is equal to 2? Well, we know it's not 5 divided by 3. Is it 2 to the... Yeah, it's not 2 to the power of 2. 2 to the power of 2 is 4. So I can go back and choose that, 2 to the power of 2. This one was... Did you say that one?
Mm-hmm.
I would agree. 3 goes into 5 one time with a remainder of 2. That means that the third one equals that, but let's make sure. The 3 to the power of 1 is, in fact, 3. All right, what does this expression evaluate to? What gets done first? Addition or multiplication? Easy stuff. Multiplication gets done first. So 2 times 3 is 6. 1 plus 6 is 7. Plus 4 is 11. What does this one evaluate to? All righty, got to do that.
3 plus 12 is 15.
Yeah, so 1 times 2 is 2. 3 times 4 is 12. So 2 plus 12 is 14.
2, oh, it's 2 plus 12.
Yeah, yeah.
Oh, yeah.
What does this evaluate to? All righty, so you got to do the parentheses first, but inside the parentheses there's a multiplication, so that happens first. 3 times 2, 6, plus 4, 10. Add 1, 11. I would strongly recommend doing this exam, doing this on your own again, right? I mean, if you're hurriedly going through and writing the answers down, great, but go through it again. Write a line of C++ code that performs the following expression. Now, what's wrong with that? What's wrong with it is two things. One is that 2x isn't going to work. If I do a is equal to 2x, no, the computer doesn't know what 2x means. I have to put an asterisk there. And the other thing that's wrong is we're going to have to group this inside parentheses, aren't we? We could even group the top one in parentheses, but that'd be useless. There's no reason to do that. But I could, if you felt like it. And then the bottom part would need to be in parentheses. And you know why? So they would do all that math before doing the division. So then it'd be 3 asterisk x plus 1 between the parentheses. Does that make sense? Everybody good with this? Giving you all the answers? Alrighty. So assume the area of a circle can be calculated as this formula. Given this code, write a line of code that will replace the comment. What goes here? We're calculating the area. So, final double PI. Apparently we're not satisfied using CMath to get it in. So final double pi is equals that. And our formula is equal to pi r squared. So what's our area equation going to look like? Area equals pi times, and then what would the rest of the expression be? There's two ways to do it. So pi times,
Power 2.
yeah, POW r comma 2, or POW, or not even POW, right? Pi times r would do it just as well. Either one would work. Which is an integer type? Longs or doubles? Longs are integer types. I don't even know why I have long double, because there's no difference between that and a regular double. Which can hold a larger and more precise value.
Long double.
Yeah, long double. Now I could get into an argument with myself about which one is more precise, because a float is an approximation, whereas an integer is absolutely bang on. But larger, we absolutely know that a double. Oh, and this one should have been a letter as well, right? Just type in A or B, whatever. If you wanted to store someone's weight, would you use a float or an int? Really, you'd use a double, but
Float.
we're all really weight conscious. We want to be able to handle fractional weights. We would need something that handles fractions. It should be a float. How about counters for whole numbers? Well, in that case, it's going to be an int. True or false? If both operands of division are int, the result is an int. Yup, that's true. Write a line of code that will cast y to an int and store the result in x. There's 3 ways to do this. If you're going to take y and cast it to an x, 3 ways. X equals int y, that's one way. X equals parentheses int in parentheses y, that's another way, and then the lengthy way, which is actually the preferred way. It's the way that makes you look fancy and stuff. And there are reasons for it, but when you're just dealing with primitive data types, I think it's okay to use one or the other. Static underscore cast less than int greater than close open parentheses y close parentheses semicolon. Any of these 3, all 3 of these things are about equivalent. All of them will give you the same answer. Which is more true? You should use getLine every time you read input, or you should use getLine only if the input will contain spaces. Well, we haven't been using getLine until one day last week, so I don't think you have to use it every single time. You use getLine if there's a space in it, and we went to some considerable effort to show what would happen if you typed in data with a space and you weren't using getLine. Then it would leave that in the buffer and store it into the next variable that came down the pipe. So you're not going to use getLine unless there's spaces in the input. True or false? I'm enjoying the class. Well, I hope you click true, or whatever. Get credit either way. If you're going to use I/O manipulation, which one do you use? What's our header file? We just used it in our example. I/O manip. How about math functions? CMath. If you Googled it up and typed in math.h, I'd probably give you credit. But anyways, to use the random function to generate a random number, which # include do you use?
Time.
I would actually have to look it up. Time is one of them, but it's not the one that brings in R and D. Yeah, why don't I see it? Phooey. Well, that's what Control F is for. PowerPoint. It's like CSTD Live. Yeah, there it is. You use CSTD Live in order to get the rand and the srand function, and then you also need the time function in order to set the original seed. So you would not have been like completely wrong in that, but the answer that we really wanted was CSTD Live.
In Python, it's just time, right?
Random. If you're going to import the random library, you do import space random.
Oh.
Yeah. So CSTD Live, we'll bring that in. Which one of these sets how many spaces will be used to display the next piece of data? Fixed? Nah. Set precision? Well, that doesn't say how many spaces are going to be. There's only one left. Set W specifies how many columns on the screen your output's going to be. And what is the I/O manip that sets how many digits will be displayed after the decimal point? Has to be set precision if we've already established what set W does. True or false? Set W has to be called before each element to be formatted. Now I'm going to give you the answer to the next one, which is that to give all of these 2 digits after the decimal place, we only had to send set precision once. Set precision works for all the data afterwards. Set W actually does not. Like if for some reason I did this, set W here, and I set this equal to 40 columns, it'd be kind of ridiculous, but I could. And then when I run it, are all of the variables 40 columns wide? No, only one. So set W has to be used before every piece of data to be formatted, but set precision not. Once we set the precision to 2, all the numbers wound up being 2. So if we go back there, set W must be called before each. Yes. Set precision must be called before each, not just once. That's false. All right. Hope that makes sense. Hope that's okay. Take it again on your own. Let me grade it first if you've already entered all the values so that you can scroll and look up, you know. And that's always true. I always have to grade these things by hand after you've taken it, and then you'll see me add a comment like, good job, or look at number 14. Until you get that comment there, I haven't laid my eyeballs on it. So even if you can go in and look to see which ones you got wrong, you'll see something marked wrong, and you'll wonder why it's wrong. It's just because I haven't graded it by hand yet. Anything that's a fill in the blank, I have to grade in by hand. Even if you think you got an exact match for what it was looking for, it might not count it right. It's infuriating. And the only way for me to get around that would be to make them all true, false, and multiple choice, and I really don't want to. So, all right, so we're moving on to chapter 4. What are you doing? Why are you loading up YouTube? Stop that. Because I accidentally clicked on our YouTube playlist. I can explain it. Work this time. Making decisions. This is going to be if statements, less than, greater than. We probably know all this stuff already. There'll be a little bit new. This chapter may be one that we cover like in 2 days. Let's see. Relational operators. These are all binary operators, meaning that they have to have 2 operands because you're going to compare x to y, right? Or x greater than 3, or x equal to 3, or y not equal to x, right? You always have to have an operand before and after a relational operator. And we know how these work. We've been doing these for a long time, since grade school probably. For example, if x is 10, is that true or false? Well, the answer is right there, so it's real hard to figure out. But anyways, is x equal to 10? It sure is, because they said x is 10. So is x not equal to 8? Is that a true statement? Even if we didn't have the answer there? Let's think it through. Is x equal to 8? It's false. So x not equal to 8 is true. Which means that x equal to 8 is false. Do not confuse single equals and double equals. Oh, and by the way, you will occasionally see C++ and C programmers take advantage of the fact that you can use a number all by itself as part of the if statement. Why you would want to do this, I don't know. But if I did this, int z is equal to 0, and then if I did int z, or if z, see out something, else see out the other thing, it's not going to print hello. Why? Because what it does is it takes that variable and it checks to see if it's non-zero. If it's non-zero, the first case executes. Else the second case executes. You will just see people very occasionally take advantage of that. So for example, I could write a while loop like this. Z is equal to 5, while z in parentheses, open curly brace, see out z, and then subtract 1 from z. And it's going to print 5, 4, 3, 2, 1. And then when it comes back up here and z is now equal to 0, well, 0 is false. And so it's going to kick itself out of the while loop. I would not code it like that. I would say while z is greater than or equal to 0, or while z is not equal to 0. One of the two. But you can do that. Is there any advantage to doing it this way? Not really, not in most circumstances.
If it has a value other than 0, it's going to be true?
Exactly. Any other value other than 0 is true as far as if statements are concerned. Pardon me?
It's a couple less keystrokes.
Yeah,
That's
yeah.
like the only benefit that I
Yeah, yeah. It's a couple of keystrokes. I can't really think of hardly any time when I felt like I had to do it that way. But you can. But normally you're going to use equal equals, right? Or less than or equal to. What you need to care about is if you did this. While or if z equals 1. See out. Gotcha. And it is going to print 1. Even if we did this. I mean, it is going to print gotcha. If we make it like that. This looks like a correctly written if statement at first blush. But it's not. It erases the value of z, replaces it with 1, and then it checks. And so it'll print gotcha, even though we thought that we were comparing it to 1 and it would only print gotcha if it was equal to 1. Well, sure enough, after it does that, it's equal to 1. Right? Or if we did this, z is equal to 0. If z equals 0, see out, less than, oops. Is it going to print oops? It oughta, right? Z is 0. If z is equal to 0, print oops. No, because what happens? Since there's a single equal rather than a double, it assigns 0 into z, erasing whatever it was before. And so now it's just if 0. And so it's not going to print oops. Weird, isn't it? So always make sure you use your double equals. Unfortunately, this compiler under Windows doesn't even seem to flag it as a warning. Maybe I'm wrong about that, but it certainly will compile. It's not a syntax error to do that. And it's almost never that you actually would want to do it that way. All right, I'm going to delete all that, having said that. So don't confuse equal and equal. The if statement. If raining, take an umbrella. If cold, wear a coat. If temperature less than 32, print freezing. If we already understand computer logic, print we know what an if statement is. The general format, in this language you have to have the parentheses, unlike some languages where you could get away with doing that. If the expression is true, it performs that. This is called the header, and this is called the body. The body can be just one statement. If it's multiple statements, you have to put braces in there. So in this case, it would have been if cold, curly brace, wear coat, wear hat, wear gloves, in curly brace. But if it's just one statement like this, it wouldn't need the curly braces, although you can put them there anyways just for clarity. Do not place a semicolon after the expression. This is like one of the easiest typos to make. I thought I deleted all that. Anyways, let's say I did this. If z less than 10. See out less than 10. I can already get the idea that something kinky is going on because it back-tabbed itself for me when I typed it. And I might just get irritated and hit that over. All right. Well, in this particular case, it would look like it would run correctly. But if I did this, if c is greater than negative 100, that should be true. But it's not going to print this. It's not going to say that it's greater than negative 100. Why? Because what this is translated as is though it is written like this. Exactly like that. Putting the semicolon there fleshes it out inside its little brain to do this. So is z greater than negative 100? Yeah, sure. Okay, do nothing. Never do you want to do nothing, right? So, putting a semicolon after an if or a while, very bad news. You can create an infinite loop real easily by doing something like this. While z is less than 100, semicolon, z plus plus. And I go, oh, well, how come I back tabbed it? But I know what I'm doing. I insert the tab again. What's it going to do now? Well, it's going to loop forever. Why? Because that gets replaced with this. While z is less than 100, do nothing. Nothing ever changes the value of z. So it's definitely going to be an infinite loop. That is one argument for doing the brace placement that some of these programs default to like that. Because if I had a semicolon there and then I had the curly brace, it makes it real obvious that the syntax is incorrect. That's about the only argument I've seen for that style of brace placement, besides the fact that you can just squeeze more code on the screen because you don't have a blank line. I greatly prefer that, but it makes people kind of want to put a semicolon there. You just got to remember that anytime there's an open curly brace, there's probably not going to be a semicolon on the line above it. That's one way to think about it. Another way to think about it is just never put a semicolon after an if or a while or a for, and then you'll be good to go. I'm going to get rid of all these bad examples now. Expanding the if statement. You can use a curly brace in order to give yourself the ability to type in more than one line of code as your body. So that's a block of code. If else. One thing or another. If the expression is true or non-zero, do that. Else, do that. And either statement can be a block of code with curly braces if you want it. See what I mean by we're going to get through this chapter quickly. So if number modulus 2 is equal to 0, that means it's an even number. You divided it by 2, you had nothing left over, so print out that it's even. Else print out that it's odd. So if you wanted to print out all the even numbers, here's one way you could do it. X is equal to 1. While, parentheses, x is less than or equal to 20, in parentheses. And let's check to see if that number is evenly divisible. So if x mod 2 is equal to 0, it's an even number. So cout, less than x, less than, quote, is even, backslash n, end quote, else cout less than x, less than, quote, is odd, backslash n, end quote, semicolon, right? Like that. And there I go. Infinite loop. Why? I never increment x. I never change the value of the loop control variable, so if this is true one time, it's always going to be true. All I need at the bottom is a little x plus plus, and then I'm happy. All right. 1 is odd, 2 is even, 3 is odd, 4 is even, and so on. You can have if, elif, else.
ELIF.
I goofed on that. There is no elif keyword in this language. If, else, space, if, else. So for example, if for some reason we just love the number 7 and we want to print a special message out about 7, if x equals 7, cout I love 7, backslash n, semicolon, right? Else, if c equals 8, cout less than I hate 8, backslash n, end quote. Else, cout less than
X.
I don't care.
X equals 8.
Yes, I need to fix that. Thank you. Where'd I come up with C? All right, there we go. Right. It's a three-way. If we got x equal to 7, it does that. If that's false, it executes this one. But if this is true, it does that, and then it jumps to the end of the entire if-else-if block. Right? It's not like it checks this one and then continues on and does this one. If this one is true, it does that and then jumps down to here. It's all done. If this is false, it goes ahead and performs the second check. If the second check is true, it does that and then it jumps down here. If both of these are false, that one has to be true. And it performs that one. Yeah. So it says something about 7, it says something about 8, and the rest of them are I don't care, which is pretty annoying to see. Nested if statements. If statements are nested inside another if statement, it's essentially an and. If you have two if statements nested in another one. Oh, cool, cool.
It's just saying one is odd.
Yeah. So you're gonna have to do the same thing I did, which is put the curly braces in and then do x plus plus. Or you could even just say x plus plus right in your test condition. Just do this. That's kind of a C programmer thing, not a C plus plus. Go up to that less than, and before that less than, right there. Yeah, and plus plus there. Now I never recommend doing this. Yeah, go ahead and delete that one. That would be great if it was inside the curly braces.
Okay, so it has to be inside the curly braces.
Right. So you're gonna have to kill your lab. All right. So our problem is that there should have been backslash in rather than forward in, but it did kind of work. But what you'd really want to do is use the curly braces like this. Putting that XX in the header, excuse me, putting the XX, the plus plus in the header is more of a, it's clever by half than what we normally want to do. And I'll show everybody. What if I didn't want to have that there? I don't know why that would be the case, but I could do this. I could do like x plus plus or plus plus there, right inside the while loop. And it would increment it only once, and then we'd have to do the body.
What happened here is that instead of starting at 1, it starts at 2.
Exactly, but it starts at 2 because it immediately adds 1 to it
Yeah.
while it's doing the comparison. And so if you get an old school C programmer, they're really fond of doing things like that. And so I just want you to recognize it.
Can't you just set x equal to 0 to fix that?
To fix it, I would do that. That's correct. I would do that. Now, there's certainly nothing wrong with doing it that way. This has higher precedence than the less than equal, so it would certainly do that first. And now it counts, 1 to 20. Nested if statements are like the AND logic. If something, and then if something else. So like int hunger is equal to 10, semicolon. Int money is equal to 20. So we have a little bit of hunger and we have a lot of money. If parentheses hunger is greater than 0, we're going to think about what we're going to do. If hunger is greater than 0, cout less than I'm hungry, backslash n, end quote, semicolon. Now we're going to check to see if we have money. If parentheses money is greater than 0, or maybe $5. We don't think that we can go out and eat for less than $5. If money is greater than 5, cout, let's go out to eat, backslash n, end quote, semicolon. Else, we're going to print some kind of message, like cout, let's stay home, backslash n, end quote. Okay, so this is a nested if statement. This if is tucked away inside this if. Now, if hunger is not greater than 0, it's not going to do any of this stuff. It's only if this is true that it's going to come in and do this stuff. And you can nest if statements inside of while loops, inside of for statements, inside of if statements, right? You can just keep, nesting as many times as you want to. Just keep increasing your indentation to make it clear what you're doing. Like this. Are you employed? Yep. Are you a recent grad? Yep. Display congrats. You qualify for the interest rate. Now, if they're not employed, we're going to say, sorry, you must be employed. Go get a job. But if employed is yes and recent grad is no, we're going to display you must have graduated from college in the past 2 years. And we could write that one, but it would look exactly like the one that I just did, right? Except I didn't put an else on mine for the third case. I only display these 2 cases. So I guess I could say if hunger is not greater than 0, I could tack my else on here. Else see out, never mind, not hungry. Backslash n end quote. Now I'm going to take out a lot of these curly braces just to make it a little bit easier to read, maybe. Maybe it's easier, maybe not. That's just about exactly their example, except the first if is to check to see if you're employed. And after that, the next if nested inside it is to see if you're a recent grad. How recently did you graduate? And if both of those are true, we print, congrats, you get the special interest rate. Else, sorry, you don't qualify for the interest rate. Else, you must be employed. Now that's kind of almost too much if we could do this. If, parentheses, hunger greater than 0 and money greater than 5. In this particular language, the word and, the and operator is represented by the ampersands, the shift 7. See out, let's go out and eat. Backslash n, end quote, semicolon. Else, we could see out some other message. Not hungry or no money. Sad face. Right. Backslash n, end quote, semicolon. And so it did say let's go out to eat, but if we come up here and we set our money to 0 and we run it, it's going to say let's stay home, but the other one's going to say not hungry or no money. So a nested if can sometimes just be replaced with the and operator. Again, the and operator is a binary operator. It requires something on either side. Some people want to do something like this. If x is equal to 1 or 2, or anyway, no, let's not go into that example. But this is an either or case, right? Whereas this printed out 3 different possibilities. Let's go out to eat, let's stay home, or never mind, not hungry. But we made the decision that these 2 things are pretty much the same. Just like in their logic here, maybe they didn't need to know that you have to be employed or you must have graduated recently. Maybe we only need 2 things. We could have checked to see if employed equals yes and recent grad equals yes. So if employed equals yes and recent grad equals yes, print this message out. Else, print some message that kind of combines both of those blocks. You must be a recent grad or, employed or and employed. Let them know why. If, else, if. You just use if, else, if to test more than 2 conditions. If, else gives you 2 possibilities. If, else, if, else, if, else, if, right? You could have hundreds of possibilities that way. If it is raining, take the umbrella. Else, if it is windy, take a hat. Else, take your sunglasses. But it could be windy and sunny. Maybe I need my sunglasses in that case too. But whatever. Following their logic, I could do this with an if, and an else if, and an else. And unlike the Python language, it's not elif. I think Python is the weird beast in that respect, not C++. Just about every other language I've ever seen actually uses the whole words else if. So if the expression is true, or at least non-zero, do this. Else if the expression here is true, do that. And you keep doing that. And then usually it's a good idea to put what's known as a final else, a terminating else, just as an error handler. Even if you think you handled every single case possible in all your if, else ifs, it could be that there's one way to sneak through all that code without triggering any of them. And that's a case that you really care about as a programmer. When you thought it was going to do one of these three, and it doesn't do one of these three, and it doesn't give you a hint that it's skipping those, it's bad news. So you'd want to do else and then like see out unexpected state or something like that. You'd want to give yourself a clue that none of these if blocks have been performed. And we've seen this kind of stuff, right? If score greater than or equal to 90, you made an A, right? Greater than or equal to 90, you made an A. Else if your score is greater than or equal to 80, you made a B. Else if your score is greater than or 70, you made a C. Else you fail. We're rude. If you make a D, too bad. Fail. Nah, but you know what I mean. I'm not going to go and add one more else if block just to complete that example. Oh, and what do you know? That's their example. Yeah. If your test score is greater than the A score, looks like they have some constants defined up above. An A score is probably a 90, but maybe if your teacher's going to curve it, he makes the A score an 88, and the B score 77, and the C score 60, or whatever. Whatever those divisions are going to be. And here's that final else. If none of these other things were true, then you made an F. Flags. A flag is just a Boolean variable, but they also say that it can be an integer where the value 0 is considered false. A flag is just when you store the result of an expression in a variable and then you check it later, like this. Say I check to see if we're broke. If money is less than or equal to 0, here's what we're going to do though. We're going to define a bool variable, bool broke equals that. The parentheses are not necessary. I'm leaving them for clarity. So if money is less than or equal to 0, then that means broke is true. If money is not less than or equal to 0, that means broke is false. So we could do if broke, see out, better ask mom for cash. Something like that. That's a flag. Kind of silly one, but it's a flag. Right? It's storing the result of a Boolean expression for later use. And people call this setting the flag. If it's set to true, it will trigger a later action. If it's set to false, it won't. It also mentioned that you can have a numeric flag, which would be something like this. Int error underscore code equals 0. And then you could have something that sets the error code later, like if hunger is less than 0, that's impossible, right? So error code is equal to 100, whatever. You'd have to come up with a list of all the possible error codes, right? If money is greater than 1,000,000, error code equals 200 because we don't believe you, right? And so on. And then later on you could do this. If error code equals 100, then we'd print out our message, right? Else, if error code equals 200, then we print out another error message. Now I'm going to delete that example, but that's not an uncommon thing to see, really, is a listing of a whole bunch of different possible values, but there's a different way that these are usually set up. For one thing, you might want to go up and declare these as constants up at the top, all your error codes. and then it becomes a little bit more readable. So like if hunger is less than 0, you might put hunger error. And if money is greater than million, you might put, you know, millionaire. Hey, that's cute. All right, anyways, you know what I mean, and so on. So you can use an integer as your flag, but normally people think of it as a Boolean variable that when set triggers an action later. Logical operators, and, or, and not. Let me go check something. To enter the 3 sides of a triangle. So it's going to display some message like that. Please enter the 3 sides of the triangle. X equals, you know, question mark, and they're going to type in 10. Y equals, question mark, they're going to type in 20. Z equals, and they're going to type in 10. And then we're going to print some messages out. This is not a right triangle. This is not a Boolean triangle. Not Boolean? What? Isosceles. Isosceles. I may have that misspelled. Isosceles triangle. So what is a right triangle? Well, there's a formula called Pythagorean theorem that lets you know if there's a right triangle or not. And if we assume that Z is that diagonal, well, a right triangle is just one that's a 90-degree angle. Looks like this. Don't want to throw too much math at us. It's not a math class, but right triangle Pythagorean theorem. Like that. This is a right triangle. The formula is c squared equals a squared plus b squared. Or you could say c is equal to the square root of parentheses a squared plus b squared. There's a couple different ways, and I'll write the formula for you to make it easy to check. So what we're going to assume is that this is x and this is y and this is z, because if we kind of made it to where you know, any side could be which, you'd have to have 3 different if statements to check to see if it was a right triangle. So how do you know if it's a right triangle? The right triangle check is if x squared equals y squared plus z squared. That's how you check for right triangle. So what is an isosceles triangle? It's just one in which all 3 sides are the same. That's a real easy if, right? No, I'm spelling it wrong. If x equals y and y equals z. So those are the 2 if checks. And I guess we ought to have some other kind of message. Because, no, that's probably enough. It can't be both a right triangle and an isosceles triangle. So I think those are enough. And then if you ran it again, and you said 10, 10, 10, it would say this is an isosceles triangle. And does anybody remember, there's something for even values, 3, 4, and 5, yeah. And so if you type in 3, 4, and 5, it happens to be a right triangle. All right, does that make sense? That makes sense? So your program just has to ask for 3 values and then do these if checks. If x squared is equal to y squared plus z squared, you know that it is a right triangle. If x is equal to y and y is equal to z, then you know it's an isosceles. Are we good with that? That kind of makes sense? Even if we don't remember what isosceles and stuff like that is, you do now. And I'll put it in the homework. I'll flesh it out.
Isosceles triangles. Two sides.
Let's Google that up. Okay, that's how you spell it.
Iso meaning two.
Oh, you're right. Not all three sides.
Yeah, it's just two sides.
Equilateral triangle.
Yeah.
Three side, three side.
No, isosceles can still be right triangle as well. 45, 45.
Right. Okay, so we have 3 checks, not just 2. Yeah, see, y'all are smarter than me. Thanks. So the isosceles triangle check is to see if it's x is equal to y, and then the equilateral triangle is if x equals y and x equals z. And I will go back in and spell everything correctly. Pretend that I'm smart. All right, so there we go. Thanks for catching me on that, guys. All right, let's make a Dropbox and we will be done.